Welcome to a brand new episode of CCSD Earth Science. Today we're going to start our new topic of astronomy. And astronomy is a study of a lot of different things. We're talking about stars, planets, the universe, galaxies, pretty much anything that's outside of Earth, outside of our atmosphere, is going to be part of astronomy. To start off the unit, we're going to look at different models of our solar system and the different ways that people believed it was arranged. The first one is the geocentric model, which is an Earth-centered model. Geo, if you think about geology, is a study of Earth, so that's where they get the geocentric from. And in a model that's a geocentric model, everything is revolving around the Earth, everything in the universe. So that's what they had thought for quite a while, and it was suggested by an astronomer named Ptolemy. But there was one problem with the geocentric model, and that was this idea called retrograde motion, which is the apparent backwards motion of an object. If you've ever sat in a car and a tractor trailer is sitting next to you and it starts to pull away, it feels like you're moving backwards. Okay, you're not going anywhere. You're sitting in place, but it appears that you're moving because of how something else is moving. And that's the way the planets in our solar system kind of look. When you look at Mars, for example, in our solar system, when you look at it in the sky, if you study it night after night, it's going to slowly look like it's moving across. And then after a while, it's going to start to look like it's moving backwards. It's not really moving backwards. What's happening is we're passing Mars in our orbit around the sun. We're closer to the sun, and it's a little bit further out. So if you think about like when you're running around a track, when you pass somebody, it looks like they're moving behind you. Okay? It's just that you're moving past them. And that's what's happening on our solar system. But they couldn't explain that with a geocentric model because the Earth was in the center. They couldn't explain why something looked like it was going one way and then would loop back around. So that led a lot of astronomers to start looking at maybe some different theories of the solar system. And they came up with the heliocentric model. Helio meaning sun, and center, so heliocentric. And in a heliocentric model, the Earth and other planets revolve around the sun. Now, with the geocentric model, they were saying the Earth was the center of the universe. The heliocentric is saying the sun is the center of our solar system. And this was suggested by Copernicus. And with this model, it helped explain things like retrograde motion, because you've got the sun in the middle, and then Mercury, Venus, Earth. Okay, so these planets are all going around the sun. So that is the model, obviously, that we go with today. Now, some other things to look at. Revolution versus rotation. These are two really big concepts that you need to make sure you understand the difference between. When you are trying to explain the movement of objects in our solar system, you can't use these interchangeably. If you're trying to talk about the Earth revolving around the sun and you say rotation, you're not explaining it correctly, and you're probably not going to get full credit for whatever answer you're trying to work on. So be careful. So rotation is an object spinning on its axis. It's spinning like this. And the planets in our solar system are typically a little bit wider in the middle than at the poles because of this rotation. When we talked about the shape of the Earth at the beginning of the year, we said that the Earth is not a perfect sphere. It's something called an oblate spheroid, and that means that it is a little bit wider around the middle, and that's because of the Earth rotating. So Earth rotates on its axis. That's what causes night and day, and that's happening at a rate of 15 degrees per hour that the Earth is rotating. Now, revolution is an object going around something else. So the Earth revolves around the sun, and that is what causes our seasons. And that happens at a rate of 1 degree per day. Okay, it's going around in about 360 degrees, and it takes about 1 degree per day for it to get around completely. So that's where we get the rate of 1 degree per day. Okay. So be very careful, make sure you understand the difference between these two, and take your time when you're trying to explain these two concepts. Don't get them confused. Now, how do we know the Earth is rotating? We've got some evidence to help support the idea that the Earth rotates. One of them is something called a Foucault pendulum. Okay, the Foucault pendulum is, I mean, you guys have heard of a pendulum before. It swings back and forth. And Foucault, he was a scientist that came up with this idea and created a pendulum. And basically what's happening is you've got a pendulum swinging back and forth. This is a side view, you can see. And they don't move. They just keep going back and forth. Well, Foucault, he set up in a room a giant pendulum, and he put pegs around, so we're looking down at the floor now. He put pegs around in a circle. And what happened was that over the course of about 12 hours, all of the pegs had been knocked down. Okay, so if you've got the Earth here, the floor, and this pendulum is going back and forth, because the Earth is rotating underneath it, this is moving, the pendulum would knock down different pegs as it's moving underneath it. If the Earth didn't rotate, you would see 2 pegs knocked down and that's it. But the Earth moving underneath it, it's a slow process, but the Earth moving will knock those pegs down. Okay, so that's one of the big evidences that we had for the idea that the Earth was rotating, because we definitely can't feel the Earth rotating. When you stand outside, you don't feel this huge breeze because the Earth is spinning so fast. So we had to look for other things. Another evidence is the Coriolis effect, which we talked about in weather. Okay, as the Earth is rotating, it curves the winds or bends them. So that's because of the Earth's rotation. But the best evidence we have are pictures from space. Looking out at the, or looking down at the Earth from space, we can actually see, yes, it is rotating. But before that point, we had to rely on these other pieces of evidence. And there's one more evidence for Earth's rotation, which I think is probably the coolest. And that would be star trails. Now, star trails are pictures of stars moving across the sky. Now, keep in mind, they're not moving, it's the Earth rotating. And if you take a camera, and it's kind of hard to do with a lot of the cameras that are out there today, you'd have to have a pretty high-end camera. But if you take a camera and you leave the shutter open, okay, because when you take a picture, it just kind of goes real fast and it captures that image. But whenever you see blurry pictures, it's because the shutter was open too long and something moved across the image. Well, we want that with star trail pictures. If you keep that shutter open and have it focused at one point in the sky and just have it sitting on a tripod, as the Earth is rotating, it captures the image of those stars moving across the sky. And it's because of the Earth rotating. So they're really cool to see. But you're going to see different patterns depending on what part of the sky you're looking. In the north, you're going to see Polaris in the center. And you're going to see the stars are moving around it. Now, Polaris is our north star. It's the star above our North Pole. So it's not going to move, but everything will move around it. So you get this circular pattern when you look at the north. At the south, you kind of get this arcing pattern. And then in the east, they're going to be moving upward like this. Now, obviously, you're not going to see the arrow marks there, but if you cover that up, it's going to look something like that. And it's doing that because that's where the stars are rising. Okay, everything pretty much rises in the east. And then in the west, they're going to be moving down like this. Actually, I'll probably kind of erase those. Looks more like that, I guess. But they're going to be coming down as they're setting. So you're going to see these different patterns depending on what part of the sky you're looking. And like I said, that one is really kind of neat because Polaris isn't moving and then everything is moving around it. So when you're done watching this, and if you have a few minutes, just Google star trails and you'll see some really cool pictures. Or even if you get on YouTube and search for some star trail videos, those are pretty cool to see too. But there's a ton of them out there. I will show you a few in class so you get a chance to see some if you can't look at home. Okay, so this was another evidence for the Earth's rotation. So we've got some evidence that the Earth is rotating. And then we also have evidence that the Earth is revolving. And the first one here are constellations. We've got different constellations that we can see at different times of the year. A big one is Orion. That's a very predominant constellation in the winter sky. Pretty much all winter you're going to be able to find it at night. But if you look outside in the summertime, you're not going to find Orion. And then the opposite of that is Scorpio. Scorpio is a summer constellation. You can only see it in the summertime, and then in the wintertime, if you look for it, it won't be there. And it's because of our position around the sun. We're seeing different parts of the sky, and it's making those other constellations not visible. If we didn't move around the sun, then we'd see the same constellations all year. Earth's revolution around the sun also causes changes in our seasons. So we have the different seasons because of Earth revolving around the sun. If we stayed in one spot, we'd be stuck in the same season all year. Okay, so that's another evidence that the Earth is revolving. So there's evidence for Earth's rotation, its revolution, and definitely make sure you understand the difference between those two. And the other big thing were the two models of our solar system, geocentric and heliocentric. Make sure you understand what those two things are. And like I said, if you have a couple of minutes, search for some star trail pictures, and they're pretty neat. If you find a neat one, maybe if you want to post it to Edmodo, that'd be fine. Have a good day.